Hi everybody, welcome to this webinar by Uleska. We're going to take a start on the webinar now. So welcome to this webinar, which is titled, What Are You Not Security Testing? I'll be presenting this webinar on behalf of Uleska. My name is Gary Robinson. In this webinar, we're going to address an aspect of security testing that's often overlooked and which directly affects the success and ability of security testing to find issues in your software. We're not going to get very technical, though we are going to chat about some types of security issues in our examples. Just for anybody on the webinar, if you have any questions, feel free to put them in the Q&A or the chat window during this presentation, and we will address them at the end. So in this webinar, we're going to cover a few things. We're going to cover a very basic but important security management question. What are you actually security testing? We're then going to cover ASTO technologies, what they are and how they relate to that security testing scope. And at the end, we'll cover the four main takeaways from this presentation that you can apply directly to your security testing approaches and to your programs. So just to introduce myself, my name is Guy Robinson and I'm a director at Uleska. Uleska is a company that creates cybersecurity tools for the software industry. I've been in software and cybersecurity for over 20 years. Recently, I was lucky enough to be voted onto the OWASP board. Now, for anybody who doesn't know what OWASP is, OWASP stands for the Open Web Application Security Project, and it's a respected industry organization that advocates and advises governments, regulatory boards, and software security companies on penetration testing and software security issues. I'm also a certified information systems security professional, achieved a number of years ago whilst being a software developer. Now, we at Uleska have a lot of experience with software development and cybersecurity, both as software developers and as security testers or penetration testers. We've run many commercial and open source security tools during our time, and continually we see the same fundamental issues coming up at a security program level in and around cybersecurity testing. And it's a dangerous problem because it directly affects how security testing is applied to the software being developed or run. And in this talk, we'll help you understand what those security issues are so you can address them in your software development programs. So what is a security test? Now, many companies work towards making a system quote unquote secure, but do we really understand what secure actually means? Now, to understand how it's going to be in this context, let's take a contrast to a normal quality assurance or functional testing approach. Now, anytime software is actually going to be functionally tested, a developer will actually create the software first. They will take the user stories or the initial functional requirements. For example, maybe an API has to be created to transfer information between one computer system and another. And they will understand the functionality and they will develop the software. Now, from a quality assurance or functional testing point of view, the tester will actually work in the same way. They will understand the features to be developed, understand the user story, and they will develop a testing package, the test spec, as we call it, which allows them to understand all the tests they need to run to both functionally test that system and to test the edge cases. For example, maybe no data has been input, and what happens to the API then? What happens if the system goes down? What happens if a database goes down? Those types of systems are actually tested for. But the output of quality assurance or functional testing is a test spec, which will have every test that should be executed, when they're run. It will show the outputs of those tests. It will show whether a test passes and whether a test fails. Now let's contrast with that with a typical security test. Now this might sound familiar. At some gate or some time period, security tooling or penetration testing is required to be run. That security testing or the penetration test creates a list of issues that were found, and those issues then become the scope of testing that needs to be fixed. Those issues are either addressed, fixed, or they're mitigated, or they're understood to be a low risk and the system is provided without those risks there. And at that point, a system is deemed to be secure. Now that's much more of a black box than the usual QA testing. There's no security testing document that's created telling all the issues that are going to actually be executed. nor there's the same understanding and relationship to the implementation of the base feature. The entire scope of what we call security is actually the issues found by security testing. Now, that means the scope of these security tests found are actually very important, because any issue, any potential possible security issue in your software that is not found during that security testing doesn't make it into the scope. It will never be addressed, won't be fixed, mitigated, or understood. And that, as I said, makes the scope of the security testing, either by the tooling or by the penetration testing, critically important to making your software actually reach security. Because if the security issue never gets into the scope, it never gets addressed. And remember that hackers or anybody wanting to breach your software doesn't care about the security scope you actually tested. If your system is breached by an issue that was not identified in the scope, there's no button you can press or legal process by which you can say, oh, well, that's not fair, I didn't know about it. Many a company has been fined or put out of business by security issues in their software that they simply didn't know about. In terms of regulations, there is no buy that they give you on fines because you didn't know about a security issue that you were eventually breached with. In fact, they might likely fine you more because your security program didn't find the issue in the first place. And this is evidenced by the output of security testing, which is only ever a list of the security tests that failed. We don't get to see the tests that actually passed or were executed because that same QA or functional testing relationship doesn't exist. Instead, the security tool or scanner is run, and a separate team or consultant is engaged to perform the security testing. And with that separation, the development team or management don't know the full scope of what was actually run. So let's look at how this applies to security, and usually in particular security standards, which is typically the measuring stick by which security is measured. Here we're going to take a look at one of the particular security standards from OWASP. The Advanced Security Verification Standard, which I usually actually get wrong when I'm trying to pronounce it. I'm actually one of the contributors to this document. This is kind of like the OWASP Top 10 on steroids. Now, for anybody in the audience who has come across the OWASP Top 10 before, that is a list of the top 10 issues found by vendors and tools around the world within a time period. So the 2017 list will actually show the issues that were found most commonly during that time period. This means the issues that were number 11, number 12 weren't included in that actual list. Now, the ASVS is a lot more detailed. It's commonly the standard that's used by penetration testers or other commercial companies. It has 182 different types of security aspects that can be addressed in software security. One of them might be SQL injection. Another one might be cross-site scripting. A different aspect might be the ability to output sensitive information to logs or to a screen in an uncontrolled fashion. So what we've done is some research with some partners to work out what is the relationship between existing commercial and open source tooling and the ASVS list of security aspects that can be found on a particular issue, a particular system. As you can see here, our research shows around 48% of OWASP ASVS issues, now that's around about 85 security aspects, can be found at least in one shape or form by a commercial or open source security tool. Now that's not to say any one tool finds all 48%. That means to say if you ran the hundreds of security tools, both commercial and open source, you could potentially cover around about 48%. Now that means there's around 52% or around 97 aspects that are not checked by any of the tools. Now some of those are process oriented and don't really relate to a test that can be run against a developed product, but it does mean there's a number of aspects that wouldn't be covered. Now this might sound like we're about to advertise manual penetration testing, and it's very true that top class manual penetration testing, such as from a Czech pen tester or a company like that, can provide very good testing scope. However, as you could guess, the same issue applies to manual security testing. Any security aspect that doesn't get covered by the manual tester, or they don't have time to execute, doesn't go into that black box of security testing scope of issues that then need to be addressed to make us think we are secure. Remember that even for security certifications, the pass mark is around about 70%, meaning any security tester doesn't know absolutely everything that needs to be addressed in a security program. However, the issue with manual security testing that's been seen around the world for a number of years is that it doesn't scale and is simply too expensive. There is no organization in the world that can afford to be manually penetration testing all of their high-risk applications for every release. This becomes even more true in today's software development exercises when you consider around 90% of organizations are moving to daily releases, which means the source application is changing more and more often, which means security testing has to be applied a lot more faster and a lot more frequently. So how do we test for security? Let's focus on this point a bit more. Remember, 48% was around about how many, the percentage we considered covered by security tools. Typically, we've seen policies that use only one or two tools, and that's what they cover in their security scope. Now, here's another fundamental question, almost an inverse of what you're not testing. What do your security tools actually test for? By that, we mean, do you know the scope of issues measured against something like ASVS that your security test or tooling could find if those issues existed in your software? Does it search for all SQL injection issues? Does it find all XSS? Does it test for authentication or the likes of authorization issues? In this slide, we'll drill down a bit further into the common security tools and again ask what portion of a standard such as ASVS do they actually cover? As you can see, we've considered there's some very focused and good tools like SQL Map, XSS or DIRB that focus on one particular aspect of something like ASVS and test that very, very well. For example, SQL Map is amazing at finding SQL injection issues, but it doesn't pretend nor advertise that it tries to find any other aspect of ASVS. If we then go to other tools such as NICTO and SSLIs, they cover a bit more of the security landscape. NICTO will find common configuration issues in your web servers. SSLIs will actually look at the TLS or other certificates and do they match up with your security policy. And then we go to other very famous commercial tools, which we consider cover around 35% of the ASVS aspects. Now that means if you ran one of those tools, you could capture up to potentially 35% of the types of issues that are covered in security. Although as we'll address later on, there are other aspects that could affect that percentage. Now this also means there's an issue of 65% that aren't being covered by any tools and which we can address through other tools like ASTO. So let's visualize this into what we are not being covered. If we consider this blue or purple box, the circle, to be all the scopes of security issues that could be existing in our software. If we apply a test, it could cover a portion of those security issues. It might also be testing for stuff which will never exist in our software. For example, maybe a WordPress test of security in a system that doesn't use WordPress. If we bring in other commercial tools, we can cover more of our Venn diagram of what issues could exist in our software and maybe some that don't. And then if we extend that onto penetration testing and running other tools, we can see how this starts to affect our security policies. Are all the issues in purple or blue here issues that we will never consider in our found issues and therefore in our security scope? Are there overlaps? For example, tool G here is maybe completely wasting time because it's already finding issues that have already been covered by penetration testing and commercial tooling. This has a direct effect into the type of aspects of our security policy that we want to have addressed. But this isn't the only aspect. As we see here, the actual coverage of the security testing is only one aspect, which we're defining as security coverage here, of the actual functional and technical tests we're actually covering. Other aspects are application scope and the time of test. For application scope, we mean the elements of your application that are actually being exercised during security testing. For example, was a security tester given a specific scope to test, perhaps to cut down on time or costs? Were they told only to test public pages and not pages that require authentication? Or were they only testing a web front end and not the back end systems that an internal attacker could find holes in? For the likes of automated security tools, were they pointed at a particular user interface and not the admin interface? Remember, most web scanners can only find pages for which they have links to, either entered directly into a tool, such as a login link, or ones they find within tools like a spider. Other pages which they can't find alone and can need to be tested, maybe dynamically generated JavaScript URLs that they haven't seen, or pages only available to a different role that wasn't used during the automated testing. We also then have time of test or temporal aspects. And this simply means when was the test applied? What changes have applied since that test was done? The industry average for a piece of code being written to it having some sort of security test is 6 months, according to industry resources. This means what other functional aspects were put into your application which haven't been security tested. And if you combine then the security coverage, the application scope, and the time of test, you can see how the actual scope of security that has actually tested and that becomes part of your considered issues or security scope, which you then try to fix, can reduce and reduce over time. So this brings us to the concept of ASTO. Now, ASTO isn't the name of any particular tool or the name of any particular area. It's actually a term derived by Gartner to stand for Application Security Testing and Orchestration. And it refers to a number of tools. It's almost a category of tools, of which Uleska is one of the vendors producing the tool in this market. Now, ASTO products orchestrate security tools and testing. They understand the aspects of the application to be tested and have configured lists of tools to be run to organize that and actually be able to execute it. The ASTO tools work by automating the security tools, either open source, commercial tools where the customer already has license, or custom scripts that are created by companies like us or penetration testers to cover some of those 52% of the ASVS that isn't covered by other tools because they're more specific to the application. Automating these testing tools allows temporal security to be covered a lot easier because these tools can be orchestrated and automated nightly, weekly, or whenever a continuous integration trigger happens. For example, maybe a Git input or a Jenkins build. The ASTO tools also orchestrate these tools by knowing the best way to call them. They understand what aspects of a web, say a web application or an API or a web page, and what tools make sense to run against those different aspects. Maybe which tools are going to be storing, which parts of a product are going to be storing information in a database rather than a flat file. And the ASTO tools also correlate the results from many security tools that have been run, bring them into one database, moving duplicates, and correlating the issues together. If you imagine that you're suddenly running hundreds of security tools, there will be multiple issues found, there will be issues that are false positives, and there will be different aspects of issues that are discovered by different tools. This all requires engineering effort to be able to bring that together and correlate them, and that's what ASTO tools can provide. The alternative is an individual or a penetration tester or security tester running these tools manually, having to bring the disparate outputs of various tools together and have that analysis. Now, with over 3.5 million unfilled cybersecurity jobs around the world, the cost and the ability to bring in those security testers is getting harder and harder for businesses. So in all, ASTO products allow customers to quickly automate and orchestrate multiple security tooling against all of their applications, quickly allowing them to know what security issues are in their current code or portfolio, rather than waiting 6 months or more and risking breaches within that time. So this then brings us to our key takeaways. Essentially, running more tools gives you more coverage. This goes back to our security scope. If only one tool can provide 1 or 2% of the security coverage, or other tools up to 35, if you run more and more of those tools, that provides more scope of your Venn diagram, as we had, to be able to find more of those issues during your testing program and bring that into your security testing scope so you know what secure actually is. Our second point is faster detection also equals more coverage. Being able to run these tools daily, if not weekly, allows you to check the issues being introduced daily into your system. So whenever you do data releases or weekly releases, you have a faster ability to be able to detect those newly input issues rather than waiting 6 months. Better app analysis also equals more coverage. The ability to be able to orchestrate those tools in a way that exercises them to the full against the various interfaces or aspects of your application. For example, some tools don't cover APIs at all. Other tools concentrate a lot more on things like XSS or SQLi, which returns information back to the user. Having that intelligence really allows to have better coverage of your security scope. And then risk translation actually moves to better actions as well. One of the aspects of the Uleska product allows these technical issues to be automatically translated into what we call value at risk values. That means instead of having the information of a medium or high SQL injection, you actually know what the business risk could be in dollar values to some of those issues. For example, you could have a tool report 2 SQL injection issues. Now, if we then understand that SQL injection 1 is against a public interface, not authenticated, and affects PII data, or SQL injection number 2 is internal only, has to have 2 or 3 levels of authentication, and only affects public information, we can make a determination that the SQL injection 1 is a lot more of a risk to our business because of the ease of use, the ability to attack it, and the regulatory fines that could be affected by it. And VAR translations allows those stronger issues or more sensitive issues to be raised to the top so they can be addressed a lot quicker. So that then covers their webinar. That is the issues that people have with web security programs, the ability to cover all the security they need to do and understand what secure actually is. We've covered ASTO products, how they address these types of issues and how they allow automation, orchestration, and correlation of the many types of issues that can be found. And we have our key takeaways here to allow us to understand how we can better cover our application security programs. With that, we can then get to the point if we have any Q&A for our programs. I'll just go and check if we have any questions coming in. Okay, with no questions on the Q&A angle, just to go to the chat window. Is there anybody that has any questions on the issues addressed during this webinar? So the question coming in, if there were a large organization using third-party suppliers, could I test their code? Yes, absolutely. So at the security test level, there's 2 main types of testing. One is called SAST, which investigates the source code and allows that to be able to determine to see if there's any security issues in it. And the other one's called DAS, which is dynamic security testing, which takes a installed version of the product and runs tests against it, almost as if it was a logged in person doing a penetration test. Now, for third-party suppliers, typically they will not release their code to allow that to be tested, but you can absolutely run the DAS testing. In fact, we do that for clients where we allow them to have that system installed somewhere either publicly or inside their own environment, and we can orchestrate and automate all of those tests being run against that system to automatically produce the report and dashboard to see any issues that were listed against it. Now that's then combined with the type of data used in various parts of the product and the strength of issue, and that allows the purchasing organization to understand what is the issues with that piece of software that's been written, whether that be a third-party supplier off-the-shelf code or whether that be something that's explicitly written for them. Okay, we have another question coming in. What are your market observations of the ratio of developer time, tester time, security tester time, and what do you think it actually should be? Well, this comes back to the issue of a lack of skills within the software security industry. As I mentioned, studies show 3.5 million unfilled cybersecurity jobs in the industry worldwide. Now that will include security managers, it will include people who are analyzing, say, stats or programs within an organization, but it will also include penetration testers and security testers who have the technical ability to run these security tests. So what we find is typically developer time is a lot, developer and QA testing time is a lot longer on any project. Like obviously systems have to be functionally proper, they have to be created, and they have to be able to achieve the functionality that was desired. Now typically what we see is the security is an afterthought, is thrown in potentially months, if not years after the software is actually developed, and is given a fairly tight scope because of the cost. This wouldn't be unheard for a couple of £1,000 per day to be the cost of a security tester. So this is one of the aspects that the ASTO set of tools and set of products in the industry are addressing, because if you consider the time that a security tester, a manual tester is actually executing, they are in one way using these same security tools as part of their toolkit, but they're adding their own intelligence in. What ASTO tools do is they wrap that intelligence of how to run the tools and how to interpret the input into an automated product, which allows you to more effectively wrap that automatically and systematically into your security program without having to pay a person day in, day out to be running those programs. Now, absolutely, there are some aspects of security issues that would never be discovered by an automated issue. But what we find and what we've seen in the industry is whilst an automated tool wouldn't discover that issue, once it is discovered, that can then be scripted or programmed in such a way that other instances of that security issue can then be slotted in, plugged in to an ASTO product to allow that to be found in other aspects or other parts of the product. So that then, as I mentioned, the custom tools allows these ASTO products to extend their reach beyond the 48% of issues that can be typically automatically discovered, but also making sure those extra percentages that are covered are very specific and very important to the application that's being tested. So we have another question here. Do we think the ASTO is suitable for businesses of all sizes? So that's very true. What we find is there are two ways of answering this question. One, your large organizations do have security budget and do have security programs. However, we find that they don't have enough to stretch to every release of every application. So ASTO provides more scalability, more automation, more orchestration to those programs to allow them to be able to do a lot more measuring. Now, what that also finds for large organizations is that those companies can start to establish trends as they are going through security programs. If you're imagining daily, if not weekly, checks of security for, say, one particular project, you can see over a period of a month or 6 months, is security getting better or worse for that particular project? You can then say, well, I'm going to try security training for that particular team. I'll maybe try a different tool. I'll maybe try another program to try and improve the security of that. But because you are measuring it day in or week in, week out, you can actually see the effect of that as opposed to other teams. And also what an ASTO product allows you to do is bring together that different results from lots of different teams amongst an organization. So as a region or as a whole organization for tens of thousands of employees around the world, you can see how various security programs are being effective or how they're not being effective. For small businesses, we find that ASTO products actually allows them to scale a lot easier. So small businesses are the ones who are usually more strapped for cash, more strapped for time, and definitely don't have security expertise within their smaller teams. But an ASTO product does allow them to bring a lot more security scope and coverage to their security testing program. So whereas instead of them just running one tool and I'm assuming that gives us security, they can run this into their daily program. They can easily integrate that at a cost-effective manner that allows them to easily report to larger businesses that they're selling to on the security of their systems. Okay, but another question of how safe is my bank? That's a question I cannot unfortunately answer. Even if we could release the results of any banks we work with, that's not something we're able to do on a webinar according to our NDAs, etc. Okay, and the final question for this webinar is an ASTO approach. Does it suit cybersecurity challenges in all industries? So that's a very good question as well, because a lot of the cybersecurity tooling that exists right now typically is targeted for telecoms, for finance, for SaaS level products. We have had engagements with, without releasing names, we've engagements with the defense sector because they find that their types of security issues in their web and software systems is a different type of issue than is normally discovered in telecoms or the finance industries. So what an ASTO approach allows you to do is, because it's very plug and play, because you can plug whatever tooling you like into the system, as long as you can understand the outputs and as long as you can intelligently execute those tools, you can actually have a different set of toolings that are focused on the different industries you have, trying to find different types of issues. An ASTO approach then allows you to take those specific tools or custom scripts or custom programs you have for that industry, integrate them into the same taxonomy or database of all the issues or results, and again, do the same automation, the same orchestration, and the same trends analysis going over time, which allows you to attack those other industries as well. Okay, that's our final question. What we'll do now is we'll make it come to an end of the webinar. I want to thank everybody who's attended. I want to thank you all for your questions. Our next webinar coming up will actually be concentrating on what we call value at risk translation, that ability to take a technical issue or a set of technical issues, understand its context of the issues within the application. For example, is it a public interface? Is it sensitive data or not sensitive data? And translate that into a monetary value. So for example, the chances of you being breached this year are X, and the monetary value of that breach would cost Y. That allows people to quickly understand and prioritize the issues they need to address first, either before release or understand the risk they have going live. And that'll be the subject of our next webinar in January of 2019. I want to thank everybody for their attendance. You can contact us at the details showing on the screen now, or contact us at uleska.com. Thank you very much.